Oh, you ready?
Yeah, let's go.
Alright, let's go. So let's bring that back. So hey everybody, my name's Ethan.
I'm Alona.
And today we have an awesome science vlog prepared for you.
Yeah, today we're gonna cover acid rain.
But wait, 1 second. Acid rain, that sounds kind of scary. Are you sure we're okay with all this rain we've been having?
Ethan, you're ridiculous, but don't worry. Acid rain has some pretty bad consequences for our environment, but it doesn't mean you shouldn't go out and frolic in the rain like I know you love to do.
Thank goodness, because you know what? I don't think I cannot frolic in the rain.
Anyway, back on topic. Essentially, acid rain is what we get when pollutants from things like our cars and factories and fossil fuels go up into the air and then wind up in our water.
But wait, how does that work exactly?
Let me show you. So the first thing that we need to understand is something called the pH scale.
Oh, I know what that is. Let me explain. To first understand what the pH scale is, we can look at water and its molecular formula. A single molecule of water is made up of 2 hydrogens and a single oxygen atom. So you can write water's formula as H2O, showing the number of each kind of atom.
Now that we have taken a look at water, we can talk about the pH scale and what it tells us. The pH scale is a way of describing whether a solution is acidic or basic. This might sound a little crazy to you at first, but don't worry, we're gonna get there. An acid is a compound or molecule that when placed in water produces more H atoms or hydrogens. A base is a molecule that when placed in water produces OH, also known as hydroxide.
The pH scale is a continuum from 1 to 14, with 1 being a really acidic compound and 14 being a rating for a really basic compound. And then the rest of the numbers describe everything in between. The number 7 on the pH scale represents molecules that are neutral or perfectly in between acidic and basic.
Excellent, Ethan. So now, as you might have guessed, acid rain is what we get when an acidic molecule is placed in water and produces more H's.
Right. But how does that relate to pollution?
It's all about the acid rain-water cycle. When pollution is released into the air, it can react first with the oxygen in our atmosphere and then the water in our clouds to create water with a higher amount of H's than normal. There are 2 types of the most common pollutants that contribute to acid rain: nitric oxide and sulfur dioxide. Here we see a single molecule of nitric oxide reacting with oxygen gas in the atmosphere. The resulting nitrogen dioxide can react with water to produce nitric acid, which is the culprit behind acidic water.
And pretty much the same thing happens with sulfur dioxide when it's released into the atmosphere. Sulfuric acid is ultimately produced in our rain, which makes our rain more acidic. This looks like trouble, Alona, especially for the environment. Recent studies have exposed the harm acid rain has on our ecosystems. For instance, acid rain removes important elements like calcium and magnesium from the soil. This greatly reduces the ability for things to grow in the soil and contributes to widespread deforestation.
The acid rain also gets into the lakes and streams and forests and other ecosystems that have water. This means that the water that fish live in and that animals drink out of becomes more acidic, causing them to suffer.
Wow, so with acid soil and acid water all together, the animals and our ecosystems are really in danger. Aw, poor little guys. But you know, Alona, it's not just our ecosystems that are vulnerable to acid rain.
You're right, acid rain also has the ability to dissolve limestone, which is a naturally occurring basic substance. Monuments such as the pyramids of Giza and the Sphinx in Egypt are made of limestone, and when they contact acid rain, it causes a chemical reaction to occur that literally dissolves the pyramids and Sphinx away.
That's why the Sphinx doesn't have a nose. Mind blown.
And there you have it, Ethan. Acid rain in all its detrimental glory. And why don't you put that thing away before you hurt yourself?
But I don't want to get the acid rain on me.
Like I said before, you, just like anyone else, won't notice the effects of acid rain directly. It's not gonna burn your skin or anything crazy like that.
Oh.
I know we talked about that.
You know, Alona, I guess you're right. And it's a really great reason to think about the pollutants that we put into our environment so that we can better preserve it.
And there you have it, acid rain.
Acid rain.
Alright guys, thanks for watching, and let us know down in the comments below your thoughts on acid rain.
And join us next time on Ethan and Alona's
Vlog of Science!